Thing is live, YouTube live being recorded. This is for all of your information. Okay, so we completed this mobility management aspects of mobility management in last lecture. So in a way, what I want to say for IoT is that this mobility part of IoT is when it comes in the picture when your IoT nodes, they are connected to the internet, and these nodes are having their location changing dynamically. So any aspect, it is not necessarily that it might be a smart vehicle, but a consumer wearing smart watch can be also what you can say what you can say dynamic node or mobile node, and this for every what you can say such node, mobility has to be management. So we have to, so application infrastructure, then that specific overall ecosystem that we'll have to develop for that. Okay, so this enterprise mobility management we have seen. So applications, devices, API, and backend, various technologies which are coming from it. This is another what you can say such exhibit where different technologies which enable you this mobility can be seen, and along with the what you can say various layers of applications and enterprise deployments are seen here. So here you can see here at application level, third party applications can be seen where your maybe smartwatch applications or your mobile applications which provide IoT. For example, one is Blink server is there where you can see what is the sensor value or the sensor dashboard. Okay, that is the idea. And but from that mobile screen to actual physical entity which the sensor is measuring, various layers are there. So here at one end you are having this thing. So here one WSN node can be seen or gateway device here, and then these are the nodes measuring some physical quantity, and they are it is having Bluetooth connectivity. Then you are having this Wi-Fi devices, and here you can see this various end nodes or end gateway devices connected, and then Wi-Fi based no this repeater and this range extension devices are there. Then there is one another aspect. Then GSM connectivity, your mobile network. We have seen mobile network like that in India we are having Geo, then Airtel, kind of thing. So that GSM network where GSM gateway connectivity and then user front end and back end, this connectivity is there, mobile connectivity. Then Zigbee connectivity, that is another protocol used by these wireless devices for data exchange. Then various API, SNMP, REST, OGC, MQTT APIs for collecting and exchanging data. This is the other what you can say uh, entity or layer or component which is coming when this mobility management is there. Then here this API they use various protocols here, simple network management protocol, Q4S protocol, PGM protocol, and then for this management they are having application programming interfaces, APIs, and further connectivities. So all this is the full ecosystem. See, that's why every single node when it is there, as I said from this part. So it is, for example, you can say this is Blink API or sensor. The things parts are there. Things part. So all these APIs now this data is displayed. So lots of things are coming in between from this point one to from this point two, and what business they do here. That is mobility management is there. Here it is API interface is there, and here it is actual BI, business logic and business interface, and you are having one end-to-end application in place. Okay, so yes, same thing here, but their layer, what is these stages or phases or layers and their job: gather, collect, then stream data, manage data, and analyze data. As I said, no BI SaaS application, and BI part is here, business analytics part, business intelligence part. Then say here you can say server layer, edge layer, and client layer. So here we are having smart sensors, then gateways and actuator. They collect the data, then gateway device. They collect data from full deployment and stream data to this higher application. This cloud here, the cloud deployment comes here, and that API layers, and then this cloud data and SaaS. It gives you one what you can say overall end-to-end application experience. Okay, So that's why your device management, business operational intelligence management, data management, all these things are there. So this question, this actually definition comes for 2 marks. Handover management. What is handover management? So it enables, it is a process which enables the network to keep active connections during the mobile terminal. What is mobile terminal? This is the mobile terminal. Movement or even balance network load every among different areas, only among different areas. So last lecture I gave example of this hexagonal cells and two hexagonal cells, and every cells has got its base station, and then this mobile device. When this mobile device is moving from one cell to other, this if mobile device is connected to this cell, and when it moves out, it should be connected to this cell. So that process, when mobile terminal movement or even balance, this is one thing. Then what happens that suppose in this area, okay, hundreds of mobiles are coming for some reason during traffic period. So this mobile has got capacity of 100 terminals, and suppose there are 150, and all of this actually this extended range for this can be like this, and this cells even overlap. So what happens, this mobile management process will do, okay, it will connect 80 mobiles here and 80 mobiles here, so that load is evenly balanced. That is the other, what you can say, uh, process which is involved in handover management. Okay, so that these cells are evenly loaded. Okay, so in the net, there is called as network control handover. The network decides based on the measurements of the received radio signal from the mobile terminals and number of bps, whether it should be accepted or it should be hand over to the other, what you can say, network, depending on where this mobile signal is coming. It is coming as strong signal or coming as weak signal. So depending what mobile will be handed over to the next sale. Okay. Now this is the next part of the discussion, that is the protocols which are used by our IoT deployments. And one questions or one important thing is IP version 4 and IP version 6. Now very first lecture, I told this thing that by 2025, more than 50 billion devices will be connected to internet, and this number is going to be exponentially rising. So what is happening in IP version 4, the address is bit is 32. There is 4 byte, 32 bit address, and because of that, as this device number is going to be increasing exponentially, what will happen, it will first of all it will surpass the overall no overall human population. First of all, beyond that, you will need to manage this device which will be connected to internet. So your this IP version 4 will have limitation that you will not be able to give this IP address to each and every device. Currently, we are having IP address scarcity because of this IP version 4 32 bit. So we are moving, majority of internet deployment, they are moving for now IP version 6. Very important thing in IP version 6, it is 128 bit address. It is 128. So it can address the need of exclusive IP address for the future, and that will fuel the growth of our IoT. Okay, so some of the features, I don't want to teach you IP version 4 or IP version 6, but the limitation with IP version 6, IP version 4 is 32 bit. Major improvement that in IP version 6 is 120 bit. So that will be an impetus for IoT. So IP version 4 is connectionless protocol, simple virtual communication layer over device by device. It requires less memory and 32-bit digital numerical address. So easy to remember. In case of IP version 6, this address are no, we have to add this hexadecimal character to that. Then it is the supported protocol by majority of devices and offers video libraries and conferences to be possible over IP addresses. IP version 6, it is hierarchical addressing and routing infrastructure. Then stateful and stateless both. Then quality of services, you can know there is always there what you can say, package drop, connection time of connection lifetime, all these things are there that will decide how much will be the quality. Is what will be the loss when you are transferring package, how many retries will be there, What is the probability of successful transmissions? This is better in IP version 6. An ideal protocol for neighboring node interaction. So mainly that is one of the IoT requirement. Okay, that is why IP version 6 is preferred over IP version 4, and that is now slowly that is getting adopted by many of our internet deployment, including IoT, non-IoT, everywhere. Because now IoT is not anything which is separate. It is simple internet of things. So other things which are there beyond these things, they are our normal network devices, and all of them are supposed to be coexisting and working together for new applications and user experience. So for that purpose, we have to go for a protocol which will support and give a rich experience over time, and that is IPv 6. So yes, that's what efficient routing achieved by using flexible address, hierarchical addressing, as it is in IP version 6, and fragmentation at source and host discover path of maximum transmission unit. This is actually related to the way you actually address the device. You form nets, you form subnets, and then actually give the address space to the device. And then for that purpose, you have gateway device and routing devices. How many hops are there? How many, what you can say, transmission units and data carriers is there? All these things have IP, because now whatever problems with their IP version 4, people have tried to address in IP version 6. Okay, then efficient packet processing achieved by reviewing the checksum process. For all packets, now there is no checksum. It is depending on the application. Okay, and that's why the IP header is light in case of IP version 6 that will come. Okay, and checksum is put in the extension field to make IP header more flexible and mobile. So this will allow your low cap device to effectively and efficiently process IP version 4 packets. Okay, so it has got better security. Okay, it is using IPsec protocol, and auto configuration helps in getting care of the addresses. Then, as I told you, IP version 6 has got more address space to cover high demands of addresses in the next 20 years. Okay, so that's what 128-bit address space. So 2 raised to 128 is the possible address space now. Earlier it was 2 raised to 32 only, but now we are having 2 raised to 30, 2 raised to 128. Okay, so end-to-end transparency. Okay, so that's why less use of network address translation. That's why many devices can communicate with each other directly, including this improves the security. Okay, some other features said easy management, multicast process for using bandwidth in efficient way. So direct data flows are supported. Scalability. So from very small network to very big network, it is easily scalable in case of IPv6 addressing. So here you can see the address of IP version 4. I told you is 8 bit, 8 bit, 8 bit, 8 bit, 32 bits are there. So it is 128 bit. Here you can see alphanumeric character is here. So hex characters are there. Hmm. So this address is hexadecimal address. Hex characters can be seen. Okay, so binary and this group of 4 they are displayed as hex characters. So here it is IP version 4 header. You can see lots of fields are there, and it is IP version 6 header, which is very light and easy to parse. So source address, destination address. Here you can see source address, destination is 32 bit, 32 bit. It is 128 bit, 128 bit address. Option padding is to make the what you can say packet length even, or to match to a specific time to live TTL. Here hop limit is there. Then version, traffic class, flow level, payload length. Hmm. And here you can see some of the fields which are common, some of the fields which are removed. Here these fields are removed, and name and position change TTL protocol. Here you can see, and new field in IPv6 flow level. That this is IPv4 header, and 6 header, lighter, flexible, and more acceptable header. So almost this is one of the last what you can say slide. Uh, but here, what important thing is that maybe for understanding for Viva for job purpose, this is IoT stack and this is a web stack. And believe me, in future, you will have almost overlapping or the difference will be what you can say removed, and there will not be separate IoT or web stack. All devices will be having capacity to communicate each other. Only something will be light, something will be powerful. So here you can see now IoT application device management. Here you are having web application. Then data format binary JSON CBOR. Here HTML XML JSON. An application layer COAP MQTT XMPP AMQP. Here in case you are having HTTP DHCP DNS transport layer security secure socket layer. The transport layer you are having UDP DTLS, and here TCP UDP. Internet layer IP version 6 IP routing, here IPv6 v4 IPsec, and here IP version 6 low power wireless personal area network. So 6 LO WPAN, this is IP version 6 low power wireless personal area network protocol. So and here main is wireless support is required, IoT stack. And for network, that's why you can see IEEE 8 group 15.4 MAC, 15.4 physical layer, physical radio, mod later is there, wireless. Here Ethernet, DSL, ISDN, wireless, everything. Okay. So this is very important. How this no information is going to flow from one layer to other, who is going to carry that thing, what data format, these two comparison. So this is our normal web stack and we latest this IoT stack. So we stop here, and next lecture we'll conclude with this differences between IP version 4 and 6. Stop the broadcast.